Okay, trigonometry. We want to explain things in the lesson. Because maybe we've been doing some questions and some people do not understand it. I think we've lost one person. Maybe it's connection. I'm not sure. Connection problems. That's fine. We'll catch up. Can you all see my screen?
Yes, sir.
So, if I have a right-angled triangle, a right-angled triangle is a triangle that has got a 90 degree. The other angles we are not worried. As long as I have a right-angled triangle, okay. If I'm given any two sides, if I'm given any two sides of a right-angled triangle, I can use Pythagoras.
Yeah.
To find the other side. So what we know with Pythagoras is the longest side, c squared, is equal to a squared plus b squared. Are we together? If I was to find any other side smaller, I have to subtract. So for example, I wanted to find b, to find ab, which is b. So to find ab there, I would say, to find that, I would say c squared minus a squared is equal to b squared. So it's only when I'm finding the longest side that I add the squares. Okay, are we together? If I'm finding any of the small sides, I have to subtract. So for example, what I'm saying is if I had this is 13 centimeters and this is 6 centimeters, to find this side, because it's not the longest side, I have to say this square. So to find x there, I have to say 13 squared minus 6 squared, square root, like that. Are we together there? Clear?
Yes, sir.
If I was finding, it's only when I'm finding the longest side that I add. For example, I don't know this, but I know that this is 4, this is 3. So to find this now, because this is the longest side, hypotenuse is now x is equal to 4 squared plus 3 squared, square root. I only square when I'm finding the longest side. And we only use Pythagoras if we are given two sides of a right-angled triangle and we want to find the third side. So you can't use Pythagoras theory if you are not given the two sides. You only use it if I'm given any two sides of a right-angled triangle and I want to find the third side. Is that clear with everyone?
Yes, sir.
Now, when I'm not given like this, and now, okay, so we say we have a right-angled triangle again, but this time now we are told one of the sides and we are given an angle. Let's say for argument's sake, this angle is 30 degrees. I don't know this side, X, and I don't know this side, A. Are we together? Now, there are some properties of triangles that we need to know straight away. So if I have a triangle, a right-angled triangle with angles like this, okay, a right-angled triangle, let's draw a better triangle. So if I have a right-angled triangle, there are some properties that we need to know there before we apply your Sokata or Chashota. So if I have a right angle triangle like this, and I have this angle as theta, are we together? And I have this as the right angle, which is the longest side if I'm just looking at this. Let's say this is A, B, C. Which is the longest side if you are looking at this? Shaman, which is the longest side?
B.
B? Longest side is B? B, C, B, or BC, that's the hypotenuse. So we call that the hypotenuse. Okay, hypotenuse there. That's the longest side. Then the side where the angle is sitting, we call it what? Adjacent. Because that's where the angle is sitting. Then the side that is opposite the angle that we are talking about in question, this is what we call the opposite.
Opposite.
Are we together there? The reason why I'm
Yes,
saying that is you have to be careful. You can be given a question like this. I'm going to twist this question. So now I have a right angle triangle, but the angle in question now is this, theta. So again, A, B, C. Which one is the longest side? Again, is this, I can tell. But which one is the adjacent?
CA.
CA, not AB, because it's where the angle is sitting in question. So this is the adjacent. And this side is opposite. This angle is the opposite. Are we together there?
Yes, sir.
Yes, sir.
Yes, sir.
So according to your syllabus, you can, depending on your schools, you use Chash or Tao. Okay. I'm not sure which one you use or which one you are good at. Some use soccer tower. Is that true?
Yes,
Some
sir.
schools, I think they use this. Soccer tower. Soccer tower. The dice. Is that true? Some schools use
Yes,
this.
sir.
Some schools use that. Okay, that's fine. Doesn't really matter, but let me show you something that you can always remember. If I'm using cos, if you want to write it down in your notes, if I'm finding cos or sine, because this is always easy for you to remember. If I'm finding cos theta or sine theta, I always divide by h. Are we together? I always divide by the hypotenuse. So cosine theta is always opposite over hypotenuse. Cos theta is always adjacent over. Clear? So you see, I'm
Yes, sir.
always dividing by the longest side. When I'm dealing with cos and sine, I'm always dividing by the longest side. So that's what you need to remember. Okay. Once you remember, then this becomes easy. Maybe the tan, that's what you have to find a way to remember that tan is opposite over adjacent. Okay. So let's look at some questions or some applications of this. Let's say this is 1. So let's say this is 44 degrees. And this angle here is, this one is 6.7. And I'm asked to find x. And let's say we have another triangle. You can draw those triangles in your, wherever your revision notes or something. Okay, let's say we have, this time we have this angle, 66 degrees. And we're given the longest side as 17.2 centimeters. And I'm being asked to calculate x. Okay, like that. So what I would do is I would ask myself, is 6.7, what is this? Is this the adjacent or opposite? Or hypotenuse? What is this? It's opposite the angle in question. So this is opposite. Then this x, is it adjacent? Yes, that's where the angle is. So it means I'm using tan. I can't use cos or sine because cos and sine deals with the hypotenuse. It's not there. Are we together? So it means tan, the angle that I'm given, 44 degrees, is equal to what? Tan, we said tan is opposite over hypotenuse. So what is the opposite? 6.7 over
6.7
x.
x.
Are we together? Cross multiply. So that will be x tan 44. Never multiply anything this side. It's always the number before the angle. X tan 44 is equal to 6.7. Divide both sides by tan 44. So x is equal to 6.7 divided by tan 44. And what does your calculator give you? Your answer should be to 3 significant figure because it's a side, it's not an angle.
6.94.
6.96. 94.
Yes, sir.
Okay, 6.94. Now let's go to this side. What do we have? What are we given? What is this side? It's opposite the angle, so it's the opposite. And this is the longest side, hypotenuse, like that. So straight away it's sine from that. So it means sine, the angle we are given, 66, is equal to, remember we always divide by that. So it's equal to what? The opposite x we don't know over 17.2. This one is easy. X cross multiply 17.2 sine 60. And what do you get from your calculator?
14.9. So 15.7, sorry.
So what did you get? 15.7.
Yes, sir.
Yes, sir.
15.7. Okay. Now let's look at another thing. So that's one way. Okay, I was just showing quickly. Now we can also be given two sides and we want to find the angle. So we are given two sides. We don't know this angle, x degrees. I am given maybe this side as 4.5 centimeters and this one maybe as 12.9 centimeters, like that. Then let's say I'm not given this angle. I am given again, maybe this time we're given this as 5.8 and we are given this as 9.7, okay, centimeters. Then we want to find the angle there, okay? Okay, let's do these two facts quickly. So again, let's look at what we are given. This, we say the way the angle is sitting is adjacent.
Yes, sir.
This is the longest side. So what am I going to use, cos or sine? What's wave?
Cos.
Cos. So I'm saying cos the angle x is equal to adjacent. You always divide by the longest side, divided by 12.9. Are we together? Now the difference with what we're doing, we were given the angle. Now we need to find the angle. So cos theta and sine theta will always give you a fraction. So this is a fraction, but we want the actual angle. So to find the actual angle, I'm now saying x is equal to arc cos, which means second fraction cos in the calculator, 4.5 divided by 12.9, like this.
So 69.6
60.
degrees.
9.6 degrees. It's always one decimal place if it's an angle. Okay, like that. Now let's do the next one. What are we given? The longest side. And this side is opposite the angle, or it's opposite. So it's sine theta. Sine x is equal to what? 5.8 opposites over the longest side, 9.7. Then x is equal to arc sine, 5.8 over 9.7.
So I get 36.7.
The rest, can you confirm his answer? I said 36.7
degrees.
Okay,
Yes,
I hope this is yes. This is very clear with F.
Yes,
Now
sir,
let's look at
that's-
the other two. Sine, where some of you struggle. Sine rule and cosine rule. So we mainly use the two for non-right angled triangles. Non-right angled triangles. Are we together? Non-right angled triangles. Let's start with the sine rule, which is the easy one. Sine rule. Then I'll explain certain things there because you might ask me reasons. But why this, why that? Okay. The sine rule. So let's draw a nice triangle there. Then we explain as we go. So if I have this as A, B, C. Okay, A, B, C. Okay, so these are just, okay, I'm sure you get to where I'm going. And let's simply say this A, B, C. Okay, it's fine. I can do it in any way so that you don't have to memorize this. Let's say this is A, this is B, this is C. So all I'm simply saying is this is A centimeters, the length of this. If I want to write A being is equal to A centimeters, that's what I'm talking about. BC is equal to B centimeters, it can be meters, doesn't matter. AC is equal to C centimeters. Okay, are we together then? This is just an example. So let's say I want to find this side here. Okay, maybe let's do this. Let's do this so that, okay, maybe if you are drawing a diagram in a nose, let's name these angles. Let's name it even in let's say 8 degrees. Maybe let's use different letter. Let's say M degrees. Sorry about this. Let's use a different letter. There's a reason why I want to do this. Yes. Don't worry about that. We can use any. The reason why I'm using something different, I want it to be very clear to everyone. Okay, why degrees like this? Okay. Are we together? So we've got a nice diagram like this. Let's say I want to find A, this A here. A, to find the length of AB. To find AB, which is 8 centimeters. AB is opposite what?
C.
Yes, it's opposite which angle?
Y.
This A is opposite to Y, yes. So I would say sine Y over A. Are we together? Is equal to, but it's all about pairs. It will make sense just now. Maybe it will make sense not because we are not using numbers. Is equal to this pair over this pair. So I can now say sine M over C is equal to the other one is that pair and that pair. So sine Z over B. Are we together? Clear?
Yes, sir. Yes, sir.
Now,
that's when.
The other thing that I need to mention, I think one of the students asked the other time, is why I can't, because I think maybe in school you are taught something different. Now I need to explain that thing. So what I need to explain, which you need to get now. If you are starting by an angle like this and a side, and then if you're saying equal to something, then you also have to start at an angle. If I had started with a side like this, to say A over sine Y is equal to C over sine M, is the same thing as this. All together. So if you are starting with the angle and the side, it's equal to the angle and the side. It has to remain the same. If I am starting with a side like this, and that is equal to the same. All together. Let's just prove it quickly so that it makes sense to you. Let's prove it quickly then. So let's draw this shape and see how we use sine real quickly. So if we have a shape like this, then we are told that this is 60 centimeters. Then we are told that this is 70 centimeters. Then we are told that this is 7 centimeters. Then 70 centimeters. Okay, that's fine. Then we are asked to calculate x altogether to find the length x. So let's prove it that is the same what you've just said. So if you want to start with the angle, because this angle is opposite that, so I can say sine 60 over 7 centimeters is equal to sine what? 70. 70 is opposite what? X. Like this. Are we together?
Yes, sir.
Cross multiply. So we now have x sine 60 is equal to 7 sine 70. Are we together? Then divide both sides by sine 60. X is equal to 7 sine 70 over sine 60. What do you get? Use your calculators.
So you get 7.60.
7.60. Okay. Are we agreeing with him? 7.70.
Yes, sir.
Okay. Divided by sine 60. Okay. 7.60. Okay, I agree with you. Now let's do the other way that some might have been taught, and we prove that it's just the same thing. Okay. So if now we're doing the side first, I would say 7 divided by, what is the side opposite? Sine what? 60.
50.
Is equal to, again, because I started with the side, I have to start with the side, x over sine 70. Cross multiply 7 sine 70 is equal to x sine 60. Divide, can you see that is the same thing? 7 sine 70 divided by sine 60. Same thing. Are we together? We arrive at the same answer. Clear?
Yes, sir.
It has to be very clear. Okay, maybe let's look at one last. So this is easy. We use it when we have what pairs. Huh? So depending on the question, for example, sometimes you can be asked to find an angle. Okay, maybe let's look at one more to find a side. Then we look at finding angles. Okay, so let's say, let me use from the book. So let's say this is 47 degrees. And this is 12.2 centimeters or meters. Let's say it's meters. It's not up to scale. Then okay. Then let's have another one. Okay, let's say I want to find an angle now. Then we don't know this angle is x degrees. Then this is 19 meters, like this. So now we want to find an angle. We have a pair, So we only use what that when we have pairs. Are we together? Pairs like that. Because I have the side opposite an angle, I have that opposite that. So I've got a pair, then I can use that. So I can now say sine 47 over what, Shamin? Sine 47 is opposite which side?
12.2
is equal to sine that we want, sine x over 19. Cross multiply, I get 19 sine 47 is equal to 12.2 sine x. I'm not sure if it will work because I was just using it from my head. Now sine, so it means 12.2, I can divide both sides by 12.2. Then I get sine x is equal to 19 sine 47 divided by 12.2. That's sine x, which is a fraction. So there's something that I need to mention straight away. Sine 47. No, it will give you an error. Okay, it's fine. I knew that it was going to give you an error there.
It's 1.13.
It will give you, because sine can only be between, because I was just using my head. Sine can never be greater than 1. It's between -1 and 1, the value of sine theta. Sine theta has a range, maximum is 1. Then if it gives you 1 point something, it's wrong, because I was just playing around with this. Are we together then? So otherwise, okay, 12.2, 19. Okay, let's give it a small value there. So instead of 19, maybe just write 8.8 meters there. Change that so that this is 8.8, and this is multiplied by 8.8, and this becomes 8.8. So when you get this, if you are using a sharp calculator, I need to because if you are using a Casio, you can simply say x is equal to arc sine of all this. But a Casio cannot do this. That's what I wanted to mention. 8.8 sine 47 divided by 12.2. So you find that your Casio, the old sharp calculators cannot do this. So what you do is you find this from your calculator. From a sharp calculator, you can do 8.8 sine 47 first. Then you divide. Once you get the answer, you divide by 12.2. Then when you do that, you go to second function, you type arc sine. Are we together? That's how you use your old calculator. I need to mention that. If you're using an old sharp calculator, you do 8.8 sine 47, then you press equal, then you divide by 12.2, then you find your answer, which is a fraction. Then you press second function arc sine. But if you're using these beta Casio calculators, you can do this. Give you the answer straight
Yes, sir.
Is that clear?
Yes, sir.
So what answer do you get?
31.8.
Okay. Because you have to be confident. Okay, 31.8 in terms of how you use that. Is that clear with everyone there? Now let's look at
Yes,
cosine rule. Oh, still hope for some minutes. Cosine rule. The tricky one, which is not difficult. Okay, it says 10 minutes. That's good enough for us. Lose 5 minutes of that. So now there is instances where we can't use what? We can't use sine rule. Okay. For example, let's say I'm given two sides. This is 7.2 centimeters. This is 9.4 centimeters. And I'm given an angle. Let's say this angle is 58 degrees. And I want to find the third side. Can we use sine rule? We'll be stuck. Because if I say sine this angle over that, then this one I don't have a pair, this one I don't have a pair. Can you see that? So sine rule, we can't, because we don't have pairs. We can only use cosine rule. Makes sense? We can only use cosine rule. So cosine rule can be used when we have this. Do you know that when we are using pairs, we can also even use cosine rule, but we'll be wasting time. Okay, cosine rule will be easy. So cosine rule is what we use there. Because so how do I use one? I will show you all the instances where we can use cosine rule. Number one, when we are given two sides of a triangle and an angle between the two sides and they want to find the third side. So if you want to write it down, that's number one. When I'm given two sides of a triangle with an angle between them and I want to find the third side. So to find the third side, I write this. I say x squared, the side that I want, is equal to the square of that plus the square of that. So it's 7.2 squared plus 9.4 squared minus 2 times that times that. So 2 times 7.2 times 9.4 cos the angle between them. What is the angle between them? 58. Are we together? But what I want is not x squared, is x. So now to find x, I say the square root of everything there. So I say 7.2 squared plus 9.4 squared minus 2 multiplied by 7.2 multiplied by 9.4 cos 58. Now, those that are lucky enough to be using, now, the good thing about this, let me explain something quickly so that it's clear with everyone. Now, if you are using our old friend, our old sharp calculator, if you use brackets like this, okay? Let's say I don't use brackets and I'm using a sharp calculator. I hope everyone is following this. Those that
Yes,
need
sir.
the lesson, I think I'm recording. I want to show you why it will give you a wrong answer. Now, when I do brackets like this, what your sharp calculator is going to do is going to find, it's going to do this because it doesn't extend the bracket. Are we together? So it's only going to find the square root of this. Are we together? Then it tries to add to this. So when you put brackets like this, the calculator, sharp calculator or the sharp calculator will know that I have to solve what's in the brackets first. Are we together? Then it knows that this square root will find the square root of what's in the brackets. Then it also knows that when I'm squaring this, for example, I multiply there before subtracting. So it's fine with this. So if you do this, you get the answer. Are we together? Straight away. But if you want in an exam, you are also allowed to do this. To find what is 7.2. What is 7.2 squared? I'm allowed to do that. What is 7.2 squared plus 9.4 squared? I want to show you that you're also allowed to do that in the exam. What is that? 7.2 squared plus 9.4 squared. If you're not sure, you can do that.
140 point.
140.2.
140, give me not the rounded answer. 140?
Yes, it's straight. 140.2.
140.2, like this.
Yes, sir.
Okay. Minus, what is 2 times 7.2 times 9.4?
135.36.
135.36.
36.
Cos 58. Then I put a square root because I'm using a sharp, I put brackets like this. Am I allowed to do that? Are we together there?
Yes, sir.
Then I put my final answer in whatever decimal places. Okay. Now, so that's how we can use that. Then sometimes we want to calculate an angle. I want to calculate an angle. Okay, so let's see if it works. So now sometimes we are given 3 sides, or the 3 sides, huh? And we want to find an angle. So I just wanted to look for a very good one with all the sides of the triangle. That will be the last one, last example today. I don't want to plug answers from my head. It's very fun. I'm not sure why it's not giving me what I wanted. But anyway, let's just plug in and hope it will work. So anyway, let's say we are given this side. I hope it will work. Because this I'm just plugging in. Let's say this is 12 centimeters. Maybe this is 14.2. Or maybe, okay, if it doesn't work, we'll play around with it. Like this, huh? I'm not saying it's a perfect triangle. I'm just saying, let's say, and we want to find what? This angle here, x degrees. All right, good. We want to find this angle. If we are given, so that's some number I told you. So another possibility to find cosine, if I'm given all the three sides, and I want to find of a 9 right angle triangle, and I want to find an angle, any angle. So I can actually find any angle of this triangle altogether. So
Yes, sir.
to find this angle here, this angle is opposite what? This side. Huh? So I would say cos, the angle that I want to find, which is x, is equal to. So now I say the square of that times the square of that. So 14.2 squared plus 12 squared minus 21.2 squared, like this. All over 2 times that times that. So 2 times 12 times 14.2. What do you get? So if you are using your old friend, which is your sharp calculator, find what do you get on the top? Let's solve what's on the top first quickly. 14.2 squared plus 12 squared minus 21.2 squared. What do you get?
So I got minus 1.
Minus 1 or?
103.8.
Okay, it's fine. And what do you get on the bottom? 2 times 12 times 14.2. As long as it gives us an answer greater than 108.
340 and 0.8.
340.8.
40.
Okay, so it will work. Cos x, because this is a fraction. Now x is equal to a cos of this. Negative 103.8 divided by 340.8. What do you get?